Perfect. So yeah, welcome everyone to the Topaz launch. This is just a really exciting moment. We're just minutes away from Genesis, really. So yeah, Prism is built by Prysmatic Labs, as you all know. We're a team building the Ethereum 2.0 protocol, written fully in Go. Here are the core contributors of the project, along with 74 other awesome contributors that we've had through open source. Everything has been assembled organically since day one. And we wanted to share with you guys a little bit of our origin story. To this date, there are two major block explorers that are already tracking the current testnets. For the Saphire testnet, Etherscan jumped into the party, basically creating a really nice interface that lets you understand what this could look like once it's really live. More importantly, a lot of development went into these block explorers, especially with the Bitfly team creating Beacon Chain. Beacon Chain was just an incredible experiment, and I think that really solidified Saphire as a great way to understand how validators perform, how rewards are accrued, and understanding better how to compare validators between each other. Additionally, it was a great place to explore problems with the chain. So when there were periods of low finality, there was low participation. Very easy for anyone to see that metric from this block explorer. To this date, and this screenshot was taken a very long time ago. Actually, we gone a lot further than that. Overall, the Saphire testnet had at its peak 52,461 validators, and even then, it was able to hold up to its very last moments before we scheduled it down. And Terrence will share more about kind of how that happened. But before we move on, just want to give a quick background of kind of how we got started. The reality was that it was all about timing, being in the right place at the right time. Around the turn of 2017, there was a lot of talk about ETH2, and especially before it was ETH2, it was just called sharding and Casper, right? Everyone talked about layer one scalability. Vitalik talked about it significantly in many of his talks. Unfortunately, people that were watching on the sidelines and curious about technical developments, there wasn't nearly any technical development for sharding at the time. There were just a handful of blog posts, maybe a few scattered resources, and more importantly, an FAQ that detailed how this could potentially work, right? With a lot of big buzzwords and difficult to grasp at its core. So it was around that time that many of us were just kind of marginally interested in Ethereum. We were doing other things. We were doing software engineering work in other places. And we realized that, there could be a good place to contribute and to get in. So we started voicing around the message on Reddit of, hey, interested in contributing to Ethereum. Maybe we could build something sharding related because nobody else is doing it. And very, very interestingly, met these guys that are here today. And through that Reddit post, right, we were actually, a lot of us were inside of a Gitter channel from the Go Ethereum project that was discussing sharding and kind of improving Ethereum. And through that, kind of this message first blossomed, which is the first time I kind of met Preston. He was posting on that Gitter chat about sharding. He said he would be interested in contributing to this. So I just sent him a quick message. He's like, hey, know anyone else interested in this? Back in January 9th of 2018. After that, the stars really lined up, because it turns out that I was flying into New York that same morning that I messaged him, and he was based in New York. Well, I lived in Chicago. I was just there coincidentally to meet some friends. And I'm like, hey, want to meet up? And he's like, sure, come to my office. Let's have coffee and let's see what happens from there. At the same time, everyone else that expressed interest in that Gitter channel and throughout the Reddit post was sent this email asking them, like, hey, you expressed interest in forming a team to implement the sharding specification for the Go Ethereum EVM at the time, right? We asked everyone to tell us your skill set, kind of where you come from and why you're excited about this, and we assembled this just fully, in a fully organic fashion, right? The responses that we got were amazing. We got some just really awesome folks that now we work with every single day. And this blossomed into the project that we know and love. And even before, this was called ETH2, right? The project has evolved significantly. It's gone through spec changes, like spec formations. It's gone through kind of renames, refactoring. But all in all, like, it really stays true to the ethos of Ethereum, being like this open, permissionless project in which truly anyone can join in and do something and contribute if they bring value to the table. So this is kind of what's been our road so far. We picked Go because Go is a great tool for the job. In particular, it keeps things simple. It has a particularly awesome concurrency pattern for blockchain technologies, and it has batteries included conciseness. So what this means is that when you're writing a project as complex or as unknown in terms of requirements as Ethereum 2.0, you would rather work with something that is straightforward, that works, and you don't want to really play games and kind of just be really, you don't want to try to be try to complicate things. So we picked a programming language because we loved it. It's been a joy, and it's been proven and tested for Ethereum 1.0 with the Geth project, even still evolving significantly to this day. Our roadmap is split across 4 different phases, and we're currently wrapping up the 3rd phase. So in approximately 15 minutes, we will be one step closer to Diamond. So what this means is we envision that at the beginning, we will create some proof of concept of Ethereum 2.0. We accomplished this in October of 2018 by launching our first demo release. Our second milestone was a Saphire milestone. So this is actually a public test network in which people can actually join and participate. And we were the first public, kind of nearly full-featured ETH testnet that you could do this. The next milestone was the Topaz testnet, which is what we're going to be talking about today, and we'll segue this into Terence's explanation of its features. And finally, we have the Diamond, which is the Ethereum 2.0 mainnet release, in which real 32 ETH multiples will be staked, to protect and secure the network. Even though we went through many different spec requirements, we still developed the Saphire release, which was created in January 2020. And that's been the latest testnet that's been live since, for over 3 months at this point. And yes, so I'll let Terence kind of hop in and explain the Saphire accomplishments.
Thanks, Raul. So can you go back? Yeah. So in the next few slides, I will go through some highlighted awesome features that we have developed over the course for Topaz. I want to keep everything at very high level. So if anyone has any in-depth questions or any of the cover feature, please drop by our Discord room and ask them. Any of us will be happy to answer your questions. So before we dive into Topaz, I want to take a moment to look at how far that we have gone for Saphire. The genesis time for Saphire was at January 9th. So quick calculation, that was just 99 days ago. 700,000 slots and 22,000 finalized epochs later, we had about 52,000 validators securing this testnet. And out of 52,000 validators, about 78% of validators were controlled by us. So what I personally cherish about this Saphire testnet is not only because this is the longest client testnet, not because it has the most active validators. What I was most proud of is that we were able to learn a lot about process improvements. We learned about how to better working as a team. We met a lot of awesome community members, which many of you are in the call, and then we received tons of good feedback. And some of those valuable feedbacks ultimately were reflected in the latest spec, and now it's live in the Prism code. So shout out and thank you everyone for that. And we like honestly wouldn't have been here without you guys. So next slide, please. So this is our internal dashboard for displaying the testnet stats. As you can see, there's about 78% of validators controlled by Prism. Next slide, please. Yeah, so let's shift gear and brief chat about the Topaz features. And as you know already, the Topaz implements the latest E2 spec, which is version 11.1. This is the audited version. This is the version that all the clients will be using to target multi-client testnet. 32 Go ETH, not real ETH, to deposit versus the previous 3.2 ETH. This is as mainnet as it gets, right? Every user impact configurations in this testnet is the same as mainnet. And the caching of the SSE state object and the usage of the fast serialization for the fast SSE library are both enabled by default. And before, they were behind the feature flags, which user had to manually turn on. But now it's enabled by default after going through some thorough testing. So we're confident enough to have them on default. So what it means that your node will consume less memory and perform faster for hashing block and state objects. And for network-related improvements, we have dynamic substitution of community attestation subnet that is enabled by default. So that means that your Beacon node is not a test team, will not be listening for attestations in the community subnet. You will only be listening for aggregated attestation in the aggregated subnet. So it dramatically reduces the network bandwidth and CPU cycles to verify on aggregated attestations. The initial sync speed is faster now with Topaz. I know we have been hearing lots of complaints about the slow sync times. So we have implemented various implementations for sync. And this is enabled by default as well. For my last setup, I saw about 80% faster blocks per second speed during syncing. And with the new state management service, the node periodically saves the historical state in the DB. So that means just a regular Prism node can generate any historical state at any arbitrary slot to service historical RPC requests, such as balance assignments. This is great for like explorers and data providers. And last but not least, we have the slasher service detector, what we call, this is called the slasher. It's running in our cluster by default. Shay and Ivan have been doing great working on that component. I believe we have caught a few slashable offense a couple weeks ago, so super exciting stuff here. Next slide. So you may ask what's next now with Topaz running, right? The answer is there's still so much to do. With Topaz running in the background, we'll be shifting our focus into multi-client testnet, and our sister brother client implementation teams are more than welcome to join us on the Topaz testnet as well. We want to get Prism formally audited and then prepare beta for the version 1 release. And last but not least, mainnet, right? We want mainnet release, which is the ultimate phase 0 goal. So thank you.
That should have switched us to the countdown view. So for the next 7 minutes, we can take some questions, we can talk, we can unmute, we can chatter. But really the goal is to just sort of enjoy the countdown. If you have questions you'd like to ask in the chat, now would be a great time for that.
Question in the chat, what kind of system specs are recommended? We aren't entirely sure yet, but we put out a really good estimate on our Topaz announcement. It comes down to anywhere between a Raspberry Pi 4 with 2 gigs of RAM to your modern laptop, like MacBook Pro, or anything made in the last couple of years, except for a Chromebook. Yeah, we've been seeing a lot of peer dials timeout. So with those, we're not sure yet if those are talking to Saphire nodes, nodes that are running on a crappy network, or nodes that have just gone offline and our discovery table is styling people that aren't there anymore. We haven't started investigating it yet until Topaz starts, then looking at those. So if you're seeing a lot of errors, cannot connect with peer, it's fine for now. As long as you have some peers, you're going to be okay.
People are asking questions in the chat.
The multi-client testing plan is what I think the thing that everyone is desperate to know. If someone from Prysmatic would like to address that.
Yeah, I can hop in. So for multi-client, right? Like, what does that mean? How does that happen? And how do what is considered success? So essentially, after Topaz is started and there are several epochs and there's finality, we'll begin experimenting with other client teams. So basically checking in on teams such as Lighthouse, Teku, Nimbus, trying to sync to the head of the chain. So making sure that we align in terms of configuration parameters, the network things are fine. We want to make sure that their node can first sync and basically follow blocks from Topaz. If that happens, then that's really excellent news. I believe Teku can already do that. And really the difficulty here is mostly in small configuration things. Like, oh, maybe Lighthouse expects this flag or expects that thing and networking, and maybe it can't sync with a node. So truly, it's about just making sure a checklist is met between both clients. The next step after that is the real multi-client is when you actually have a validator from another implementation running and producing blocks in the network, right? So we would ideally have a validator from Tech with Lighthouse or Nimbus, basically doing the same thing that Prism validators are. The moment we see a first block on the block explorers that was created by them, that would be considered success. And at that point, the network is basically multi-client. What a real multi-client network would be more distributed evenly across. So you would have many validators from the different teams, right? So you would have something like a even split across the network of like Lighthouse, Nimbus, Teku, Prism validators, right? And that's as distributed and as awesome as you can get. Beyond that, it would really be about ensuring that it has resilience in periods of chaos. So if there's any periods without finality or any problems, that the network can resolve them and can proceed as normal. So that's going to be also undergoing some load testing, and that's kind of what that means, right? So you guys can envision that a bulk of that time will really be in coordination and in making sure that things are aligned between the teams.
Okay, 1 minute.
Oh, let's see who gets that first block.
Yeah, if you get the first block, let us know, and we'll, I don't know, write your name on the back of Prism or something like that.
What he's doing right now.
30 seconds.
Oh, you don't want to hear from me, man. I'm so freaking excited. Have we all been sitting in the freaking vortex of shit for the last 3 years now? I mean,
has it been 3 years? No one's noticed.
Oh, no one's noticed. We've all aged 30 years, but there's so many great faces in this chat right now. It's pretty cool. I just
5 seconds.
5, 2,
get off.
1.
Go ahead.
Oh, here we go.
Happy
Look
New
at that little party.
Year.
Woo!
Yeah.
Chain started with the last
That's
episode.
what I'm
Let's go.
Let's
Not
go.
syncing.
Let's
It's
go.
gonna be-
Oh.
Yeah, see something happen.
Everyone
I
hold your
tested-
breath. Ooh, we have a testers.
I tested for slot 0.
Fun fact, the last time we did this, it didn't work for 2 hours. So kind of hoping that's not what's going on right now.
We ain't got shit else to do for 2 hours. Sit here with you, man. Don't worry.
Right. Oh, man.
We'll,
okay, I got a block.
I got block
Nice.
block 3.
Hey!
Hey.
Oh, look at that. Let me get rid of this.
Holy shit.
It's alive.
Fucking
Hey, we
working.
got blocks.
Oh, and the graph is moving.
Pog.
Oh.
Fuck.
Oh my god, that's insane.
Congratulations, Pysmatic.
I got
We got
block
another
5.
block, slot 5, yep.
Hey, hi.
And the blocks have attestations, which is good.
Looking good. That's looking good.
Nice.
Sorry, Preston, go ahead.
Nope, you go ahead, I'm talking a lot.
I just wanted to chat about the attestations and the blocks. So you guys will notice there are a few things that you see. There's like applying state transition, like 5 attestations, attester slashings, slot 16 or something like that. That's really huge news because that means that everyone is voting, well, everyone that can and that has their machine online is voting, and basically they're getting aggregated across the network. So nodes receive them and they aggregate them with other attestations that meet the same criteria, and then we package the aggregated bunch of votes into a single block. So imagine like otherwise we would be packing 16,000 plus attestations inside of one block, right? And that's such a huge block. But leveraging really cool state-of-the-art cryptography, we're able to do this, and that makes it really nice. What's also working is that you're not listening for every vote across the network. You're only listening for attestations that you care about when you aggregate. So that reduces your bandwidth usage significantly, and that's really cool because you're no longer basically spamming the network, but you're only getting the data that you need to create a block. And those numbers that we're looking at right now in the blocks look decent for us. It's a good time to chat about what happens during an epoch transition, and like maybe we can explain it in a way that makes it very very straightforward. Terrence, you want to jump in about that?
Yeah, I can try. So it's essentially epoch. So there's block transition, there's epoch transition. Block transition happens every slot. What block transition does is that you verify that the block is a valid block, right? So make sure the block is not coming from any malicious validator. So once you verify this is a valid block, you basically dissect the blocks and then see what is in the block, right? The block can contain many validator-related operations, such as deposit to register new validators, such as exit, right? Validator can exit. And then what the most important thing is that block contains votes. So it essentially is the validator's view of what is the correct chain. So then once the block is processed, the votes gets aggregated in the state. And during epoch processing, we essentially get a state and we look at all these votes, and then we start counting the votes to see whether there's enough voting power to justify or finalize the epoch. Another thing it does is that it essentially process rewards and penalties for the validators. So based on the votes that happen in the block on the per slot basis, it essentially calculate rewards and penalties. Validators gets reward if you vote the right thing. Validator gets penalty if you didn't vote or vote the wrong thing. And those are the two most important tests during epoch processing.
Yeah, maybe we can explain what justification and finality means. Like, can you add a quick note about that?
Yeah, sure, definitely, right. So justification finalization is a FFG term. So there's a few awesome posts out there on the Ethereum blog. I highly suggest people read about that. So there's a for choice and there's finality gadget. For choice essentially chooses the head on the per slot basis. So the chain follows the head, kind of similar to proof of work, right? The head is the longest chain. But for here, the head, they run something called the LMD goes for choice rule. So it chooses the head based on that. And then based on that, you apply this finality gadget, which is FFG gadget on top of that. So based on that, you can tell you essentially breaking down the entire chain into checkpoints. So every 32 slots is a checkpoint. And then during that checkpoint, if there's enough validators voting for that checkpoint, by enough, I mean over 2/3. So if there's over 2/3 of a vote on that checkpoint, and that checkpoint considered justified. And based on this rule, if there's two consecutive justified, or there's maybe like one skip in the middle, and there's one justified, one not justified, and one justified, and then the later justified can basically formally finalize the previous justified checkpoint.
Cool. Yeah. So basically, it's just like, we have enough votes for a lot of consecutive epochs that it's basically impossible to revert chain. So we mark it as impossible to revert. Nobody can come in and try to rewrite the history, right? Like, you cannot change things past the finalized checkpoint, right? That's just like, it's part of the protocol and it's the way it's designed. And to accomplish that, you need a lot of consecutive epochs of voting and voting and voting. So there are no crazy forks that can go all the way back down and basically gather enough votes from validators to revert history. Like, it becomes impossible. Yeah.
And this is an economic guarantee, right? So if you actually finalize two justified epoch in the same epoch number, then it means that 1/3 of the validators are basically performing a malicious vote, and that vote will get validator slash, which is why we have been working super hard on this slashing detection service, Slasher. Shout out to Ivan and the share working on that. So with that, we can actually detect which validators basically voted the wrong thing to basically trigger two duplicated finalized epochs.
So what we looked at today was we watched the launch of the Prysmatic Topaz Testnet. We demonstrated through 128 process slots for justified epochs, for current epochs, that the testnet is successful. So congratulations to Prysmatic. I know that everyone's here to watch what they're doing, but what they demonstrated was 2 years of hard work that came together to produce this this beacon chain client, the first completed beacon chain client for Ethereum 2. So congratulations to you all. And we have about 3 minutes to talk about what's next, what's in the future, and that's our meeting. Thanks.